Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Maximilian Moreau, and with me is Philip Wilson and Jeffrey Hawthorne. We got everyone here today. It's great. Our fill rate has been so low, so we're increasing our fill rate on this episode.
Yeah, there is a lot more fill this episode.
Yes, there is.
Maybe we should
Testing,
restart.
1, 2, 3. All right. Restart? Really?
Well, I don't know. We can.
I mean, I haven't been cutting these videos lately anyway. I'm just going to run.
We're just going to
running.
keep going!
Sorry about the audio out there. Something happened.
Something happened. At least we noticed it early on.
Yeah, truly. It wasn't like 30 minutes of figuring out what was going on.
Truly.
Could add subtitles later.
Outrageous. Outrageous.
Did you see how far down the list the 2D shooter was? That's just, yeah, wow.
That's outrageous.
It is.
Truly outrageous. Outrageous.
So links are up for the for these files, and these files also include some additional code that we haven't gone over on the show that we're going to go over today. Oh wow, this is really unorganized. Who made this project?
It's the one-armed man.
What's that supposed to mean?
It wasn't me. It was the one-armed man.
Got it. Is that some? Wait, that's
from The Fugitive.
Fugitive, yeah.
Yeah, Harrison Ford's always
Old school.
like, it wasn't me. It was the one-armed man.
So anyway, I'm going to. I saw what is that? Oh yeah, I saw Apocalypto recently, and it was the first movie I'd seen where someone jumped off of a waterfall to escape a chase, and then the other people jumped off after them. That was the first time I'd seen that actually happen in a movie.
Is that the Mel Gibson movie?
It is.
I've seen that movie.
It's a good movie. I actually really liked
Not too
it.
bad. The one
that
about
the
the
one-
Mayans
Yeah.
or the Incas. Or
And the Spaniards at the end.
Yeah.
I liked that ending.
yeah, it was
I
good.
thought the ending was really neat.
So what
Surprisingly
is
good.
Game Manager? What is this? New animation. I don't even know what this is.
I have no clue.
Buttons aren't toys.
It doesn't have. It has no. Okay, I'm just deleting this. I think this is not supposed to be here.
I like that someone said, "Stop trying to make Google Plus happen, Google."
Yeah, I mean, actually, screw it. Make Google Plus happen, but make it happen on the battlefield. Make it awesome so that no one uses Facebook anymore. It doesn't take that much. It really doesn't. Just think it through, and don't push people into it because then they'll hate you. So.
They can't be forceful.
All right.
things.
Animations. I'm just going to clean this up.
Animation.
Boss intro. Occasionally, you should just clean your stuff up so that you can find things later.
Or so you can maybe not find something that you thought you knew where it was. Because
Well,
now it's in
immediately,
another
but
folder.
later you'll know
Yes.
where it is.
Yeah.
So I was actually just going to say that is the funny thing. Yeah, fonts, materials. No, we don't even have a scenes folder. Man, we're just slacking on this. Scenes. Grab our level files. Playership. This isn't the prefab. This is like a sprite, I guess. I'll make a sprites folder.
Kenny Sprite Art.
Yeah, thank you, Kenny, for continually showering us with gifts of CC0 content to put on the show. Really appreciate it.
I appreciate it.
And Boss UFO is an animation controller. We'll create one more folder for an animation controller. Animation controller. For some reason, I thought we had more things with the animation controllers, but I guess it's just the boss.
Animator.
All right, so that stuff is together. I'm just going to go ahead and do a save. Wait, no, not the scene, just the project. This is a new scene that we don't want. And we'll do designed level. And what are we doing? We're going to hit play, see how things are. Oh, yeah, this is not the right setup. Yeah, we do, thankfully. So 2D shooter vertical, yay.
Maximize on play, turn that off.
Oh, thank you. All right. 10 minutes into the program. Well, 5 minutes into the program. But 10 minutes into when it's supposed to start, and we are at least showing where we're at. So,
Yay!
slow start, but we'll pick up the speed. So yeah, we've got a shooter, we've got enemies going, we've got a couple levels. So today we're gonna do a different type of weapon, mostly because we want to play around with some Bezier curves and stuff. And Jeffrey spent some of his precious free time doing some projects work for a Bezier curve solver and a little example scene. And we'll see if I haven't actually tested this on this project yet, so hopefully this will all just work. We may have to retag a couple things. We'll see what actually happens. But what we have in the example... Nope, it just worked. Perfect. Oh, wait. Oh, that's because I'm not actually... So... Oh, you're directly addressing WASD. Excellent, that works. So I'm actually going to move the game thing just for a moment so that... Oh. Free aspect. There we go. So this is what Jeffrey got us, and he this is based on what we were talking about with the Raiden 2. I thought it was Raiden 3, but it's Raiden 2 Purple Beam of Death thing. And he's got this going on here where if the enemies are in front, it locks in and starts beaming between them and stuff, and it looks really cool. And he's doing it with two Bezier curve solvers. One's a cubic one, and one's a quadratic, and he'll probably be helping explain what the differences between these are, but they have just slightly different characteristics and requirements. And then he has this example set up where we have this working. So I'm going to actually open up one of these. What's the simpler one to look at?
Quadratic.
Quadratic, okay.
Even though it sounds like it's not.
Yeah, it does.
But it's the mathematics, the quadratic and cubic equations. So if you think of it that way, then, you know,
it's a good point. Yeah, you learn the quadratic.
X squared,
yeah.
Cubic is x cubed.
Yeah. Good point. The quadratic formula, or wait, no, yes. I don't know what I'm thinking about. Anyway, so what you've got going on here, so you've got gizmos for this too. That's nice.
That's what.
Yeah, I noticed the gizmo.
That's so that you can see in the editor when it's not running. You can see and mess with the Bezier curve.
Very cool. That's awesome. So. Where is the...
Yeah, and so that's the gizmos right there, the white lines.
Yeah, I see those. That's
lines.
Awesome. That's really cool. It's like even if we didn't have a line renderer enabled on these things, you'll be able to see where those Bezier curves are going. That's cool.
So in the example that we're looking at now, I'm using both the quadratic and the cubic.
Yeah, so the quadratic is so like I was disabling enabling here. Actually, I guess I can stop hitting play, and then, well, actually, that's not a great example when it's not playing, but...
Well, you can modify them here if you want.
So his cubic Bezier... quadratic Bezier chain, let's start with this one. So you have the different points for the chain, and so in the case of the Bezier chain, is there a good example of a Bezier curve that I can pull up? Actually, I know what I'll use. I'll use the editor. I'll use one of the animation editors to show it off real quick. So if we go to animation, and just because I realized I didn't really introduce what a Bezier curve is. Actually, I want to switch to 2D shooter vertical. No, I don't. That was a lie. Didn't want to do that yet. After I'd done all that work.
Or you can do it on the curves here. In the editor, just turn off the line renderer, set the points to...
Yeah, I just wanted something I can kind of drag out, but I'll try it out there real quick. So let's just move the points around. So this represents... Wait.
So you have to turn on the continual recalculate
okay.
if you want it to...
There we go. So this represents the first point's position. And I imagine this represents the second point's position? Yeah.
Yes.
And then there's that magical P1, and this is the way that the line curves. Basically, it's like a point that it tries to go through or something.
It curves toward that point. It won't end up going through that point unless that point ends up being pretty much in a straight line between the two.
Yeah.
So it's always just substantially farther up than it. It's just like kind of the target point that it's using.
Yeah.
its
Would you
offset.
mind
It
terribly...
gets toward and then it comes away from that point.
I'm going to actually do something, at least for the temporary, for displaying how this works, and add another gizmo here. I want to draw the points themselves too. So
I think that makes sense.
Let's do. Oh, I equals 1, and then you use a -1. Interesting. Actually, I guess that makes sense because yeah, that makes sense. Never mind. No comment. I didn't say that.
Less interesting.
Less interesting.
Aw.
So this draws the line between.
That's the subdivision.
Subdivision
Let's
points.
draw the
Perfect,
actual
perfect.
line. So
All
you're
right.
going to want to use.
So you're going to want to use the
not the subdivisions, but the
quadratic Bezier points list here.
yeah.
Okay. So gizmos. We're gonna just draw a sphere. Draw a sphere. And it will be. All right. So we need the center and the radius. The radius I'm going to make real small, like 0.1 f or something. And then the center will be quadratic Bezier points.
Bezier chain.
Wait, why is? Oh, that's a.
So the script is actually
Yeah.
a Bezier curve is just those 3 points for the quadratic.
Mhm.
Cubic has 4 points, and so the script is actually a chain so that you can chain several curves together,
Oh, that's cool.
which is what's happening in the example.
That's awesome. So quadratic Bezier points I, and I don't want subdivision points.
It's
I want
Bezier chain I.
Bezier chain.
So is the cubic?
Oh, Bezier chain. Yeah, thank you.
The cubic would be a similar principle where it would just go between 2 points. I'm assuming.
The cubic has P0 through P3. P0 being the starting point, P3 being the
End
ending
point.
point, and P1 and P2 are
they
points that it moves toward on its.
So it would create
That's
more
fine.
like of a.
So yeah, and
Instead of just a normal curve, it would be more like an S.
you can it can be. It can also be a curve that. I mean, the quadratic creates kind of parabolic curves
Mm-hmm.
because there's only one point that it's heading through or near. But the other one, you can have the curves on the same side of the other 2
Okay.
points, so that it'll like start a very steep curve maybe, and then the curve will shallow out, and then it will head back to the
That's
final
cool.
point or something like that. But actually, you can see there the kind of S shape is what you were referring to.
Yeah.
That is where I have the pole points.
But
The
you
first
could
one is up
theoretically put
above,
them
and
anywhere.
the other one is down below. Yeah.
Yeah, that's cool.
All right. So, all right, we're almost done here.
Actually, that is the pole point. I see it in there. It's
So-
right by the S.
So what I've done here is I've added a thing where it draws the spheres of where the objects are. These are not. These are in local space, right? Like these are relative to the object, right? Or wait, no. Only if we do stay with transform. Oh, they're there. I didn't notice them. I
Yeah,
drew
they're
them
all
too
there.
small. So,
Mhm.
so let's actually play with these things now. So if we move this point, you can see how it influences the line here. So
That's cool.
kind of, yeah, like magnetically pulls at the position. And as he said, we can have a whole chain of these things, so we can add like another point element. And
So you're going to want P0 of element 1 to match P2 of element 0 if you...
Yes.
if you want it to
them
actually be
yeah.
continuous. Okay, you don't automatically do that for people.
No.
Okay, fair enough.
I don't.
That's fine. So it just does a straight line between the two if they're not tied together. Then, all right, cool. All right, implementation fun times. So in a best case scenario for using this thing right, you want to make sure that these 2 points coincide, and then you can do whatever the heck you want with the other points. So you can create all these little. Z is not really helpful in our current view.
No, but it could be
If you
kind of
rotate,
cool actually.
yeah. You're going to
In
be
certain
looking...
scenarios.
But yeah, so this is the drawing thing, and then we've got the cubic one as well, and I don't think I changed the cubic to actually draw out the points.
Probably
I
not.
don't think so either.
So, and also by default, it looks like, or at least in this project, you've got it set so that you have to turn on continual recalculate, and you currently use it as these are absolute coordinates, but you can also do stay with transform, which makes it so that wherever you move this thing to, sorry, not scale, but move this thing to, you get the movement and rotation,
Yeah.
which is cool and useful.
And transform scale is there too as a separate checkbox.
Oh, nice. So you can even scale it. Oh, that's awesome. Very cool. All right.
Continual recalculate is basically there for the editor,
Yeah.
but and the way I'm doing it in the example, I added a function where I can
Revert this scene real quick.
set a new chain, pass an array of points for the new chain, and when I set it via that function, it flags it to update. So,
Okay.
in the example, I'm pretty sure it's unchecked also, and it's just flagging it every frame to update.
Cool. That's awesome. All right, let's actually try using this thing for right now. So I'm probably not going to go over every line on how this thing works, but because it's basically math. What did you use as reference for when you were developing this?
Wikipedia.
There you go. There you go.
Nice.
So,
It's like
That's
how I
where the
made
P0
A-Star.
yep.
That's where the P0, P1, P2, and P3 come from. So if you look at Wikipedia and you see their diagram, that should...
So this is the source of the information. Anyone can get to it. This is the reason that I love being in the future, where you can just type words in and find things out as long as you know what words to type.
That's cool.
Hint: one of the words is usually Wikipedia.
That's actually where I got my A-Star pseudocode from, is Wikipedia as well.
Yep,
So.
and the Dijkstra version too.
Mm-hmm.
I actually... So I'm
Look
using...
at all these math symbols.
Yeah,
I'm
there are a
using
lot of
the...
them.
I think it's down farther, but I'm using just, like, basically the equations that they have in here for the quadratic.
Oh, here we go.
And...
Oh yeah, that's actually a really good example of how these work. These little GIFs.
That's awesome.
Oh, Wikipedia is pretty cool.
There's a lot of multiplications in the mathematical equations, and I tried simplifying it to just using mostly additions and subtractions, but it ended up taking the same amount of
Time once you.
time. Yeah. So I changed it back because it's actually
Damn you,
easier.
compiler optimization. I mean,
It's actually-
thank you, but
It's actually easier to read, I think, if you're looking at it.
Yeah.
And so, like with that GIF right there, you can see that that's not quadratic or
Excuse
cubic.
me,
They're
what did you
doing
just
like
say?
5.
yeah,
What?
That GIF? Is that what you said?
yeah,
Oh,
I think so.
oh, part of me died.
Bad GIF as opposed to bad GIF.
No, GIF.
I know it's totally GIF, even though he said it was GIF.
I
The guy that
know.
made it said it was GIF, but he's wrong.
Just
Because
reminds
choosy
me.
moms choose GIF,
I
Oh,
always called
They
it
do.
GIF also, but
but now you're gonna respect him.
I don't respect
I don't
that
respect him.
man. Wow. Wow, I was learning
The cr-
about Bezier curves when I was a little kid, and I didn't know it.
Yeah, when you drew these little line thingies.
Yeah.
They even did them in colored pencil, just
I know.
just like we did as little kids when there were no computers to do things. You were just like, I'm just gonna draw lines.
And that's what it is. It's a Bezier curve.
All right.
Interesting.
Let's get this show back on track. So let's try and use this thing, and I'm probably going to ask a lot of questions and things like that, but that's okay, because I never have enough time to actually look at things. So, what are we doing? Open project. No, we have the project open. We just want a different scene. I'm going to go with design. Well, let's just duplicate design level and call this test level. And I'm actually just going to do this because I've been doing it lately. When working as a team, it's commonly good to have your own test levels, just because these scenes don't merge so great when you're working with other folks. And I've been working with other folks lately at work, so I guess I'm in habit now. But I thought I'd mention that just because sometimes people ask, is like, so when I'm using version control and like 2 people edit the same scene file, what do I do? And I'm just like, you run. No. Actually, there's probably a solve for that. I haven't actually used this, but there's on the asset store, there's something that I'm very curious to use called Unimerge. I never got a chance to actually check this out. But it looks like if you are in a merge situation, this may get you out of it and might even allow you to have a merge workflow in the future so you don't have to worry about it anymore. What it does is it compares the values that are in the file and actually changes them. The problem with the scene files is they're text files when you set them to text mode, but they can't be merged because the order that they write is completely random. Like Unity's just like roll some dice and then whatever it comes to first, it decides to write to file. So let's see here. So we're gonna hit play. No, we're not gonna hit play. So let's get a beam going.
I'm pretty sure they even seeded their randomness in where they write out.
Yes. So we've got this barrel. They seeded. They did. So there's more random. Yes. It feels that way. Like I'll change one thing in a file, and it'll say this portion was deleted, and then like 1,000 lines down, it'll be like, and we added this one. It's the exact same thing, but with a number different. So, and if you just did merge, it's just like, oh, you just want to get rid of. You want to have 2 of these? Yeah, you want to keep these things. No, what's going on? No, all right, so I'm just going to duplicate our barrel, and we're going to call this the what should we call this? Let's call it the Bezier laser. Anyone have any good Bezier trivia? Because I was really happy with the one that I did not know on the last episode that someone mentioned in comments that that Perlin Noise was the guy Perlin actually won an award for his work on Tron. So
oh really?
Yeah.
I did not know that.
Or something like that, something along those lines. So Bezier laser, I'm going to go ahead and you don't have prefabs for these separate, do we? That's fine. I'm just going to apply this to the player. And right now it's just another layer of shooting, so we're going to change that out. So obviously this is not going to be a bullet type thing where we spawn it and then keep spawning more of them. This is going to be we spawn one and then we adjust it as it goes. Because we're basically creating the whole path of the beam, and we want to keep that thing up there and doing things. So we'll probably disable it when we're not shooting with it, and then we'll enable it when we are. And so I'm going to remove this script for right now. Remove component. We're going to go to scripts, and actually I'm curious. Maybe we can just. So we've already got your example here. You've already got some some stuff that uses this, right? So yeah, let's look at what we got for our blaster here. Let me get rid of that stupid. Okay, it's not going to come up. Fine, whatever. So we have our Bezier chain. We do particles between them. Oh man, there's so much fun stuff. Maybe I do actually want to run. Let's write from scratch here. We may actually go back and reference that, but I want to actually just get some typing going on. Makes me feel better.
To type?
To type, yeah. I know that sounds strange. So
I think it
what
might
are we
be
gonna
better
call
to
this?
go from scratch.
Bezier
Just use
laser.
that
All right.
for reference if there's something specific.
Sounds
That's
good.
a good idea.
Because there is a lot in there, and
So let's start with just the quadratic one, because that's the simpler one to use for starters. And I'm going to attach this to our Bezier laser. And I'm going to have it stay with our transform. And I'm just going to go ahead and preset this. I'm going to go continual recalculate here so we can see what we're doing. And I'm going to set P0 to be on our ship. And then I'm going to set P2 to be slightly forward of our ship, which I think is in the Y. No, the Z direction. There we go. Because this is actually paying attention to our rotation, so that's forward of the ship. And I'm going to put this point we're just going to make it look like a straight line for right now. No, I don't like that. Let's bend it. Bend it like Bezier.
Oh.
I like it.
Do too.
2.5. Wait, no. 2.5 to... Why does it feel like that's bending out weird?
Willie says it's not GIF. It's GIF, not GIF. It's a regional dialect.
It's a regional dialect. Oh wait, Z is not what I wanted. That's my problem. I want this. I want Z rather. 2.5. There we go.
You were scaring me for a second there. I'm like, no, what's happening?
What is happening to my world?
So these points actually don't perfectly represent anything right now. The ones I'm drawing, because I didn't actually put that extra code in there to handle things properly. So we can't pay attention to those right at the moment. Might fix that in a second here, but. So I'm just gonna put this in the middle and give it a nice little juke there. So there's our beam. So what we're gonna want to do is, so we've got our Bezier laser here. So this thing automatically subdivides itself so that we can use it nicely with a line renderer. And so that's what we're probably gonna do. Or wait, no, you already do. Oh, you have a checkbox.
And it adds a line renderer.
That's hot. You showed me that before, but I'm really happy to show that on the show. That's super awesome. All right,
That's
so
cool.
when it doesn't get rid of it though. I'm still very happy with that.
In case you have settings that you didn't want to delete, so you don't go, oh no.
Yeah. So that's awesome. And so if you do use line renderer, it updates the line renderer.
Well, it updates it while continual recalculation.
Yeah. Well, okay, fair enough. If you're running, does it update or?
If continual recalculate is on.
Oh, that's not. Wait, what happened? It's floating. It's leaving us. Hold on, wait. I just want to see this again.
Oh, it's
You didn't.
probably
you-
needs to be parented or child.
Connected to the player. I think.
Yeah, it looks that way.
I'm gonna click continual recalculate and see if that fixes it. Just out
yeah,
of curiosity.
because you're not.
Yes.
You're not passing.
I'm
stuff
not
that
changing
haven't
values.
changed
Okay, got
already,
it, got it.
Oh.
So we're gonna leave continual recalculate on, for
You might-
the remainder.
I'm not sure if you're actually going to want it to stay with the transform, because if you're using enemy positions,
Mm-hmm.
then you'd set those positions, but then they'd be modified based on your transform. Does that
yeah,
make sense?
I think that makes sense. Let's write ourselves into walls and then we'll figure that out. I think we'll see.
You could subtract your transform from the enemy positions when you add them.
Yeah, that's probably what I'm going to do. Something like that. Do some transform math. All right. So, wait. This is using world space. Wait, we can really confuse things. So we've got say with transform, but it's using world space. That's fascinating. Oh wait, we wanted to use world space. You set that. Okay, got it. Never mind. World space is right. I think.
I think that has to
Yeah.
always be on, because the
All right.
you can't change the line renderer settings, or you can't change the line renderer positions if you have continual recalculate on, because it's being set by the Bezier curve.
Gotcha. So, let's mock up some enemies real quick.
I think the world space always has to be on with the line renderer, because the Bezier curve is always using world space. The points are just being modified based on your transform if you decide to use the transform.
Okay. Did everyone catch all that? All right. So, yes. Yeah, that makes sense. All right. So, this is our test level. So, I'm going to move forward here.
If you call carbonated drinks soda, you call it GIF. If you call them pop, you say GIF. Is
All right, so we're
that
no
the
longer-
regional dialect?
I guess I don't know.
This is a comment from our...
We've got movement going on. I'm going to put some enemies in here. So the background's still moving, but we're not actually moving through the scene, so we shouldn't see any unexpected enemies. So I'm just actually going to put some enemies in the scene here so we can play around with them.
Unexpected enemies.
So where are prefabs?
A wild enemy appeared.
Whoosh, there's a wild enemy. And so let's start with one, and then we'll move up. Actually, I'll put two in the scene just for right now,
For funsies?
for funsies. And we'll see how we do this.
It's
So
too far out of the scene.
it's too far out of the scene.
He is too far out
It
of
is
the
too
scene.
far out of the scene. All right. Our scene's too small. All right. So let's hit play and see if things are still kind of working. Okay, we can move, And I'm going to remove their AI for right now, too. I'm just going to gut their brain. So
They are. Wait,
Fodder AI. Nope.
you're giving them a lobotomy.
Mm-hmm.
That's unfortunate.
Now they're just going to sit there like bumps on a log.
Yeah.
All right, and look, we have Newtonian physics because we're still continually moving through space. They just got a force applied to them, and now they're just flying through forever or something. I don't know. We happen to be moving the same speed. Our engines are probably out. We're all going to die. But we're going to take them with us with our laser.
I want games that are all about non-Newtonian fluids.
Actually, that wouldn't be... There's some design work you could do with that, I'm pretty sure.
I'm sure there is.
Bezier, cubic Bezier chain. So did I actually make a script?
I think there was one that was released
Yes, I did.
recently on Steam.
Bezier laser.
A non-Newtonian game?
Fluid game.
That would be kind of cool.
think.
Really?
I kind of remember something about that.
All right, so I'm going to go using system.collections.generic right now because I know we're going to need to list something in here. I guarantee that there's
think we'll
going to be
need-
a list of
you think we'll
something.
need a
Probably a
list?
list of enemies that we're going to be like horribly zapping.
Yeah, probably would
so-
be a good idea.
That's how I
I'm going to just...
did it, I think.
Perfect.
List of enemies. That way I could also
List.
remove enemies each check so that I wouldn't be checking the same ones multiple times.
I'm going to go with
Yeah, that makes
transform because we care about where they are more than we care about blowing them up. So...
Yeah, that's really all we care about is their position.
Well, if we're going to apply damage, we might care, but we might do that
We
differently.
aren't doing that right now, though.
Yeah, let's just start with this. So let's transform enemies caught, beamed enemies. There we go. All right, new list transform, and what are we going to do here? So first of all, let's get our component here. So we're going to create a private, what do we call this? So we're doing the quadratic Bezier points. Wait, is that what I
We're
want?
gonna
No,
need-
I want the script itself,
yeah,
right?
we're going to do chain
Chain,
right now.
alright.
Later we're going to do points
Yeah.
to create a list of points.
All right, so quadratic Bezier chain beam equals should I initialize it? No, we want to grab it from what we got in the object. That's right. So in the start here, we're going to set quadratic Bezier chain to be
Beam. Beam is what you called it.
beam
Nerves.
equals
Take out that.
oh, sorry. Thank you. My brain's not working tonight, evidently. I had a good day at work, though, so... just kind of tired, I guess. So, beam equals...
component.
thank you.
Neat.
Component, quadratic Bezier chain... So now we have our reference, and that should stay well enough for our tests at the very least. And so what we're going to do here is, right now, I'm just going to... Do we have our enemies tagged as something useful? Yes, tagged as enemies. Thank you. So let's start by just finding the enemies and putting points on them. I'm not going to worry about exactly where they go or anything. Let's just start with that, and then we'll see what goes on after that. So what we're going to do is, in our update here, we're going to get a list of all the enemies that that are in the scene. So we're going to GameObject.find GameObjects with tag, and the tag we're going to use is enemies. Just hard code that for now. So find object with tags enemies. This represents... we're going to make a... Actually, I'm not going to do this. Yeah, I am. Alright, so... because we're going to need it later. So transform... not transform. Yeah. We want game object list... or game object array equal... all enemies equals game object find the object with tag enemies. Alright, so all enemies. What are we doing? We are going to take all these enemies and put them in our list for right now. So I guess I can just do that really easily by just doing beamed enemies equals new list. We're already initializing up there, so we don't actually have to do this, but we're probably going to change how this works in the near future. Oh, we can't just grab all enemies anyway. Never mind. I'm not going to do it that way, because these are game objects, but we need transforms. So we're going to iterate through this for each enemy, sorry,
For each?
game object enemy in all enemies. We're going to do beamed enemies dot add enemy dot transform. And before this, I want to actually clear our list. So, sorry, not list. Beamed enemies dot clear. So each frame, this list should represent all the enemies on the screen. We're going to change it. It's not going to be all the enemies. Otherwise, this is redundant. Obviously, we could just iterate through all the enemies if we only wanted that, but I'm setting this up because we're going to be picking enemies that are within tolerances to hit. So we have the enemies, and so what we're going to do is we're going to set up our Bezier chain to hit them. So, so each point that we set up on this chain has 3 points associated with it. It has the beginning point, the end point, and the midpoint adjustment. And then if we have a full chain, we want the end points to match the beginning points of the next chain. So let's set that up here. So what does our Bezier chain look like? So beam.Bezier chain. This is an array. Joy.
Type in set.
Set. Ooh. You made a setter. That's fun. Alright, so that actually takes a list too. Excellent. So we need a list of points. Currently I have a list of transforms. We can change that very easily.
Well, the list is the chain points. So the P0, P1, P2.
Oh, wait, so this is actually, set Bezier chain. Oh, okay, so we have to set up each Bezier point first. That's fine, alright. I'm not going to change this then. I'll leave it as a transform there. Alright, so what we're going to do is we're going to have to create a set Bezier points. We're going to need a list of quadratic Bezier points. Yeah. So let's create a new Bezier point right now. So Bezier, just to see how this works. So Bezier quadratic Bezier points. Why is it plural? All right. Point equals. Oh, is
each
this
of them is
multiple points? What is in the chain? Oh,
quadratic Bezier points is one chain, which is 3 points: P0, P1, and P2.
Ah, okay, gotcha. I still would call this a point though, because it's just. Oh, I see. It's not 1 point though. It's okay. Got it. All right. So
at some point, I decided to stop trying to figure out what to name.
Yeah,
everything.
that's fine. I'm gonna just call it length 1 for right now. Quadratic Bezier points length 1. That's confusing. First length. We'll just call it that for right now. Equals new quadratic Bezier points, and this constructor takes a start, a pull, and an end. Perfect. So I like that you labeled these as start, pull, and end. That's nice. So our starting point is going to be transform dot position. That's our player position, or rather the laser position. And our pull, we're going to put
This is where you really have to think about what you want the laser to
Yeah,
look like.
Yeah.
I'm not going to worry about that for right now. I'm going to just make it a midpoint from the endpoint. So what we'll do is I'm going to put another comment there, so we have to come back to that. So our first endpoint is going to be the first enemy. So we're going to do beamed enemies 0. We're just going to do that for right now.
So
Dot position.
first length, you're actually going to want to have vector 3.0 as the starting point because you placed it on the player and you said stay with transform.
Oh, well, okay, we'll just do this. Local position. Does that solve it?
No, vector 3.0.
Why would it be 0 though? Like, why?
Because
I mean, it's 0 in this case, but wouldn't it also be 0 if we did local position? Or I guess I'm confused with how you've set this up.
You have it as a child of the player,
Yeah.
and so the positions are going to be relative to the global position of the player. And since you have it set to stay with transform, then vector 3.0 would be at the player's position. It's like if you put a cube as a child of the player and zeroed it out, it would be sitting on the player.
Okay. All right, I see what you're saying. All right, let's turn off stay with transform. And we'll just manually position it based on the positions like that. I think that's what you were talking about earlier.
Yeah, that's what I was.
All right, cool. Problem solved. All right, so we still need this point here. And so what I'm going to do is a little trick for finding a midpoint. And we're going to use vector3 dot lerp. And we're just going to lerp between transform dot position and beamed enemies 0 dot position. And the lerp value will be 0.5f. So this is our midpoint between the two. This way we're not getting a pull in just some random direction if I just set that to something strange. What happened there? I fixed it. Okay. So so let's see what this does first. Oh wait, no, we just have the length here. We actually have to set it now into our Bezier chain. So quadratic Bezier chain. Sorry, that's not what we want. Beam dot Bezier chain.
Set.
Interesting.
You can't just, there's no setter method on this. You can't, this is not. Is it better to use set to Bezier chain? Oh, because we can use a list.
Well, no, there's another set. I think you can set an individual
Doesn't look like it.
that you didn't type in set, you typed in BE.
Set. Curve and chain. Is that what it is?
Yeah. But actually, I don't think it'll add. I don't remember how that's set up. I don't think that'll work the way it's currently set up.
Okay.
Because I don't think it
Right.
adds new.
Okay, fine.
I don't remember.
Is
if
there a
it
problem with
adds new
directly?
positions or not.
I should use the setter method because. So is there a reason that you didn't set this up as a property by any chance? I'm just curious. What did we do here? We'll change it to a property later. All right. Beam dot set Bezier chain. And we need to give it a array of points. So what I'm just going to do is we're going to create a. How do we want to do this? We can do it from a list. Let's just do a list. List quadratic Bezier points. Beam chain is what I'm going to call it. Equals new list quadratic Bezier points. That's not what. Why was I doing that? I'm not making a function. All right, so we've got that list. We're going to do beam chain dot add. We're going to add our first length. And then we're going to set Bezier chain finally to beam chain. And I think I had to have something else. Recalculate subdivisions. Oh, it has a default. Perfect. So
It's defaulted to true. But
is that
it's
a good
there.
thing or a bad thing? Recalculate subdivisions? What does that do?
It makes the line.
Well, then we
basically.
want that. So
Yeah, well, it defaults to true, but it's there in case you're going to be making a lot of modifications and don't want it to actually update this frame.
all right, so if we hit play, we got nothing. All right, probably because I didn't attach a script, and I didn't. All right, so we're going to attach our Bezier laser script to Bezier laser, and we're going to hit play. And theoretically, okay, yay, we have a. It is attaching to one of the ships. Perfect.
That's good.
This is actually what we wanted it to be doing at this point. So now let's make it attached to multiple ships. So this is how we do it for one. So doing it for multiple ones should be a little bit of a, roll through what's going on. So we have the enemies transform, beamed enemies. I guess we don't have to technically if we're calculating this every frame anyway, we don't technically need to save our list of enemies. I'm going to just leave the list alone and comment that out for right now because I may eat those words really quickly. So I'm just going to copy and paste these in here. I'm going to pull this list declaration for our quadratic Bezier points out of the list, out of the for each loop, because we don't want to create a new one each time. And instead of saying first length, we're just going to call it Bezier points.
That makes sense.
And then instead of beamed enemies 0 dot position, we're going to do enemy dot position dot transform dot position, and then the same thing for the second one here. Now this isn't going to do what we wanted to do just yet. I'm pretty sure this will make it look like there's two lines coming from our ship going to each of the dudes. And there we go. There are. And the reason for this is because we're still setting it to our local transform for both of those, and we should actually be setting it to the previous position. So the way we can do that is we're going to want our position the first time. So
I mean, I would do this in a list.
You would do this in a list?
Yeah,
We're
because
already in a
I
list.
put myself
We've got the list
in
right
the
here.
list and then have the next enemy and just iterate through them.
Put yourself in the list and have
Yeah,
the
it's
next
the
enemy
first
iterate
one.
through them. Okay.
The first entry, and then you just iterate through each one.
Okay.
That's how I think I would
I
handle
like
this
that.
situation.
I like that. I like that. So,
So I'd be doing like a distance
Yeah.
check, probably getting enemies based upon distance and trying to sort them.
yeah, we will be
based
doing
upon
that.
their
We will be doing
distance.
that in a second here. I just wanted to see if there was something else I wanted to do instead of that real quick, because I had a different thought that I was going through, and now I'm having second thoughts about it. Not used to having you here, man.
Yeah.
What the hell?
I'll throw in different ways of doing things.
All right. It's good to have you back, man. Seriously.
Yeah, I know. I've been
And
way too long.
and Jeremy, thank you for providing this code and stuff. Sorry I'm muscling through it, but I mean, like, the part of the fun of this show is figuring out how stuff works and working with
I'm
stuff that you're
looking
not
through.
that you haven't done a whole lot with.
through your code right now on my machine.
So what we're we doing? Beamed enemies add. All right, let's go with your list idea. Let's do it. So let's go back to
Dang
kind of
right,
how we
we're
had
gonna
this
go
set
with
up.
my list idea. It's a good idea.
We're going to add the enemies, but before we do that, so I'm going to change this from beamed enemies to beam transforms. That's what I'm going to call beam transforms. That sounds really exciting. So beam transforms dot add, and we're going to add the enemy transform. Before we go through this, though, we're going to do beam transforms dot add, and we're going to add the player. So that's just transform. So now we've got this list. I'm going to move this back down. And so we don't want enemy transformed position here anymore. I kind of want this to be what it was before, but that's fine because it's not even called beamed enemy anymore. It's called beam transforms. I'm going to put an I here even though we haven't actually done that yet. Dot position, and we're going to do the same thing with, you know, maybe these should just be a vector. Whatever, we'll work with it. We'll just do work. We'll make it work first, and then we'll clean it up. Beam transforms I dot position. So what we're going to do is we're going to actually do I and then I plus 1.
Mm-hmm. This will run into a problem probably when it's null.
And actually we want, yeah, we'll get that covered real quick. So this one we want to be I, this one we want to be I plus 1, this one we want to be I plus 1. So what we're saying is, oh, and we want one more here. So let's actually make our iterator here so that people understand where that I is coming from. So for int I, wait, this isn't what I want to do. I can do a for each.
Mm-hmm.
It's been a long day. Alright, so for each, be transform trans, and I don't want to say transform because it'll messes up. Actually, we'll call it beam transform, and beam transforms. No, we don't want to do this. We want to do it as a for each because we need to get the next thing in the list too. That's the reason I was doing it this way. So for int I, I'm not crazy. I is less than Bezier points. Wait, that's not what we want. Beam transforms dot length dot count. One of those things. Don't know why there's both.
-1.
You're right. Less than or equal to count minus 1. We'll get there.
Don't forget to set I.
Make it crash
Also.
first. So picky. Alright, so... And this should be a Bezier... Oh, I see. Yeah, that's fine. So Bezier chain, beam chain. Alright, so... Wait, what's beam chain?
Beam chain. What is beam chain?
Oh, here's beam chain. Okay, so that's our thing. Okay. So you add the Bezier points. We're using I position.
I. Then for the midpoint, it's using the enemy's point for the moment, and then
the reason we have the -1 here is because we're looking ahead +1, so that we don't overstep our boundaries on the beam transforms. Let's see what this does. Let's see if we got something going on here.
Well, let's see. I mean, what's the worst that's going to happen?
Well,
You
first
get
of all,
that.
we got a compiler. Beamed enemies doesn't exist. That's because we changed it to beam transformed. We're going to hit play again. Yay! Okay, it's going between one and the other. It's not going in the proper order, but it's going
but I mean,
there.
it's doing what we expected.
Exactly,
it to, which is good.
exactly.
It's going from our ship to the enemies.
So now what we're going to do is we're going to... So we've got our beam transforms, we've set our Bezier chain. So now we're going to change how our enemies are ordered. So for each enemy and all enemies, we're going to find out how far away they are first, and then we're going to add them to. So what's the easiest way to do this?
Don't know what the easiest way to do this is.
So we're going to start with the float
But
min distance.
This reminds me of what I had to do for my A-star pathfinding.
Oh wait, we don't
which
even have
is-
to do. So we're just doing relatives, right? So we're gonna want a list. We're gonna want a list of distances per enemy, and then we're gonna want to sort them in some way. What's the easiest way to do that? So normally, if I was trying to find the closest, we've done the closest enemy on the show several times before. Basically, you just have a closest length, and you set that to like math f.infinity, and then you keep going down. But what we're doing here is a little bit different because we actually want a list of enemies in order of where they are.
I would probably... Well, I mean, when I did my A-star, I did a dictionary.
Yeah.
At that point, I had a dictionary where I would give it the game object and it would give me the position.
Yeah. I was thinking that would work, though dictionaries aren't usually sorted.
That's the problem. And then you'd have to. I was also using the float and getting the lowest value.
All right, what's a way? Let me actually look. Let's see if there's a tool that we're not thinking of real quick. So,
Sure there is.
Sorted dictionary.
There's a sorted list
C#.
function, I believe.
Sorted dictionary. There is one. It is in systems.collections.generic suite. So, type of the keys in the dictionary, the value of the keys in the dictionary. What does it say? Represents a collection of key value pairs that are sorted on the key. Perfect. This is exactly what we want. So, wait. No. It's not what we want. We want it sorted on the value.
Yes, we do.
Dang it.
Mm-hmm.
Sorted dictionary C# value? Sort keys and values in a dictionary. This is using link. I don't like link. I mean, like, I like link, but I like to avoid it because
List
it's
order equals sorted list. Use
sorted
link.
dictionary, but sorted by values.
Oh, yeah, that's right. This is the problem that I ended up having. I believe link isn't supported in MonoDeveloper, at least what it wasn't at the time.
Yeah, I think it's supported now, but I still want
Is
to
it?
avoid it. In case someone's using earlier .NET stuff for some reason.
I should update their .NET.
Alright.
Is link supported now in MonoDevelop? That would be pretty interesting.
I thought it was. Maybe I'm wrong. I'm not sure.
Let me check.
That was the reason I avoided it at first, but I swear that it's actually supported now. 1 or 2 microseconds. Let me see if there's something we can do with our sorted dictionary to actually make that work. So if we make the keys, so it's sorted by keys. So if we make the keys the floats and the values can, do dictionaries have, here, let's actually check. Let's open up, let's create a sorted private sorted dictionary test dict. And this is going to be a game object, comma, float dictionary equals new sorted dictionary game object float. Problem solving. So this sorts based on the key, which is the first one, which is not what we want. We want to sort based on the second one. But let's look at this real quick. So if we want to reference this, so normally you dereference it by putting your game object here, and then you get a float back, right? But is there a way to get by key? Not sorted dictionary. Sorry, test dict dot contains key, contains value, remove to string, try get value, values, yeah, not useful. Alright, our sorted dictionary is not going to solve our problem.
Nope.
So we want
For each node, it opens set keys. If it opens set keys node. I think it looks like I almost have 2 lists.
All right, let's do it. Let's do it a little bit differently. We're gonna create a class. We're gonna create a private class called what will we call this? Enemy info is what I'm going to call it. We're going to call it enemy info, and it's going to contain, and it's class, so private class.
Private class.
So we've got this public class Bezier laser, and now we've got this subclass called enemy info. I'm creating it as a subclass. We might move it outside later or even into its own file later, but right now I'm only planning on using it in this script, and so it kind of makes sense as just being part of the script for right now. And I'm not even sure if we're going to stick with this methodology, but I want to try it anyway. So enemy info, and all this is going to contain is the enemy itself, so game object enemy, and it's going to contain the float distance from player. Why am I doing this? Let's just put the. I don't want to iterate over the list so many times, though.
Mm-hmm.
I'm just going to keep coding myself in corners until this day ends, and then we can fix it next week when my brain works. All right, so float distance from player. So what we're going to do is we're going to...
I mean, technically...
I'm going to do square distance from player.
For this, we only want them within a certain range, right?
Yeah, we'll get to that in a second here, but I actually want to go through all of them first, because we're assuming that there's a bunch of enemies that happen to be within that range. We're going to have to do this anyway, because we want it to bounce between them properly, right?
Well, we can just iterate to the first one, whichever the distance is less to, add that enemy to the list, then find the next one, add it to the list, find the next one, add it to the list. As long as it's not in the list already. So if we have a distance,
and actually we do want it to be
enemies
bouncing
from enemy to enemy.
Yeah.
So we could easily do basically check to see what's in the list, move from one enemy to the next, make sure it hasn't touched any of the enemies that are already in that list, and just kind of bounce, as long as they're within a certain range. And there we wouldn't get all the enemies every frame.
All right, so
That's what I did.
Yeah, it seems like that's a good way to find out which way it's going from enemy to enemy, like within a certain range. So
I went through, made sure the enemy that I was checking the distance of was above the
player.
the current Bezier point, whether it was a player or enemy, and then would check the distance and replace it as the next target if the current next target was farther away.
that makes sense.
Until I found the closest one, then I would remove the one that I'm adding to the chain. I would remove it from my list to check.
Oh, okay, you have a list to check. Okay, that makes sense.
All right, so
And then
that
run the
makes
next
sense.
frame. And also I had a cap on how many enemies could be in the chain. So
So
after
how many
like,
it could bounce to, basically.
after like 5 bounces or something, it would stop iterating anyway.
That's cool.
all right, so let's get our nearest enemy for right now. So what we're gonna do is create a float. Nearest distance equals math f dot infinity. We're gonna do a game object nearest enemy equals null. Alright, so what we're going to do is, and I'm going to call it square distance because we don't want to use actual distance because we're doing a comparison here. We don't care what the actual distance is for right now. So beam transfers add enemy transform. So instead of doing this, we're actually going to be doing a step here where we try and figure out which one's the closest one. So if enemy dot transform dot position minus transform dot position wait. So we already added ourself to this, right? Because this isn't just enemies.
Yeah, we should be adding ourselves first.
Yeah, we're up there.
Yeah, but we don't want to add ourselves because then we'll be the closest thing to us. Oh, we'll compare it to the previous thing in beam transforms. Got it. All right, so enemy dot transform dot position minus beam transforms 0 dot position And we're going to take the magnitude of that. Actually, we're going to do this before we do the if statement because I don't want to have to calculate this twice. So dot square magnitude. So this is our enemy float distance equals that. If distance is less than nearest square distance, which it will be, almost certainly, we will then put nearest square distance is now equal to distance. I probably should have called it square distance so that we know that that's what it is, because it is. It's not the actual distance, it's the distance squared, which you can find out the actual distance by doing a square root, but square roots are expensive, so we're avoiding that. So the distance is that, and then the nearest enemy is equal to the enemy in question. So once we go through all of the enemies, so all enemies. So this is what they were talking about. They had to keep a list, and they remove things from the list as they're added. So we go through all these. At the end here, we now know the nearest enemy. So nearest enemy. So now all we do is beam transforms dot add nearest enemy, and we can now remove it from all enemies. So because we can't bounce back to the same enemy. Yeah, that makes sense. So all enemies dot remove. No, dot. Wait, what is all enemies? Oh, it's an array. Damn it. We're gonna do list game object. Swear we'll have something here in a moment here. List game object all enemies equals new list game object, and we'll use the constructor. One of the nice list constructors here takes a collection, an IEnumerable game object collection, which we can get from here. Arrays happen to be collections. It's great. So all enemies dot remove. Yay, it's there now. Nearest nearest enemy.
Mm-hmm.
All right. So we've got this is one. What were you? I saw the finger go at the screen.
Okay.
You just launched at the screen.
Yeah.
Never mind.
That's also what I saw.
This is one?
This is one, yes.
Okay.
Now we're going to loop through it. This is horrible. It's an n-squared operation, but we don't care. So it's not quite n-squared, but it's not great. O of... I'm not going to calculate it right now. All right, so we add beam transforms, nearest enemy, we remove from all enemies, and so this is what we need to repeat here. So we're going to do while all enemies dot count is greater than 0. Oh, wait. This isn't right either. Wait, all enemies. So we add our transfer to beam transfers. All enemies just has the enemies. We're checking the enemy distance to the previous. Alright, so instead of beam transforms 0 here, we actually want this to be the last in the list of beam transforms. So
That's
we will
what I was
do
gonna
is.
Beam transforms dot count -1.
Yeah.
Yeah.
Count. Beam transforms dot count -1. Actually, is there a pop? Hold on, I just want to see. Beam transforms dot pop. No, that'd be too easy. Python has ruined me sometimes. Everything has pop in Python. It's just like, well, you might use it as a stack. Who care? So, beam transforms dot count -1 position square magnitude. That looks right. Nearest enemy. And the end of the while loop is here. Wait, no, it's not. It's there. And it should be here. And these should be tabbed in. Alright, so in theory, all enemies... No, Beam Transforms at this point has everything in it that we want ordered in the way that we want it right now. It's slow-ish, but... Alright, distance does not exist in the current context. Where did my distance go from? Distance... Oh, I called it square distance, and then I stopped calling it square distance. Or rather, I called it distance, and I started calling it... You know what I did.
Yeah. What was the error?
Add... Oh, it wants to transform, so nearest enemy dot transform and dot transform. Wait, no. All enemies, we just want nearest enemy. Come on, come on. Whew, yeah. Yay, it worked. Yay, it's still working.
Mm-hmm.
Let's move the enemies around. Let's try and mess it up. Oh, that was... You know what happened
you
there.
just moved the art.
Yeah, the art. Let's grab the actual enemy and move it. Yay!
Seems to work.
Wait, what's that extra... What is it going to there? Wait, did you see that?
Yeah.
What was that?
I don't know.
Wait, what?
I don't know.
It's going to 0 for some reason. I'm not getting any output here.
Is it working
Wait.
at runtime?
And when you click, it goes away.
Yeah,
When I click,
it's
it
just
goes
when you're
away.
moving the enemy itself that seems to be a problem.
It's when I have the enemy selected.
Yeah, but that's weird. You should never have the enemy selected.
But wait, why would that make a difference? That's an editor
I
thing.
don't know why would that make a difference.
Why would that make a difference?
It shouldn't. And I think that this
What have we done?
I think this is something we should not worry about.
No, I'm worried.
We should not worry about this.
All right.
Because it's an editor-related issue. We messed with something that it obviously
we mess with
wasn't
powers that
expected.
we shouldn't be messing with, evidently.
So if it doesn't happen during gameplay right now, we shouldn't worry about it.
But it does happen during gameplay. See, it's happening
Oh,
right
yeah.
there during gameplay.
When you're highlighting an enemy.
Yeah. So.
Weird. I don't know what to tell you about that.
What?
Next time on Cooking Theme.
No,
we
but
solve
like,
this weird
what
problem.
is this? I'm going to save. Save project. I'm gonna quit Unity. Yes, I want to save it all. And for safety's sake, I'm gonna open up Perforce.
Shut them all down.
How many of the internet?
Curse my metal body.
Shut down all of the
All right, so let's reconcile offline work right now. And get us backed up in whatever state it's in right now. Reconcile, yeah, that's great. All that stuff looks good. What else did we remove? Wait, what are all... Oh, we moved things around, that's right.
Yes.
So submit, moved stuff, made things happen, and then some scary editor stuff started scaring us, so we made this check-in before everything breaks worse. If you ever see a check-in that looks like that at your workplace, call in sick. Alright, opening the project. Let's just hope that it just works and that everything's happy. Alright, we click it. If we click an enemy,
It's probably gonna do. I don't know.
it definitely did. I see it jiggling. Let's move our player around.
Yeah, we need
That's
to.
a 0 point. when
It
we
actually
click
looks
it.
like it's
Oh.
a light object.
Is it on, I think it's actually just going to 0 and the light happens to be there. So if I move the directional light, let's test that. So I'm going to move the directional light and we click enemy. Yeah, it's still
just
going
a
to 0.
point. So what's it? Where's the assumption of 0 coming from?
I was just wondering if the points weren't actually connected, and so it's. I mean,
Oh,
if
drawing the extra line or
P3
something? Yeah.
P3 and P0 weren't connected correctly in one of the
Mm,
situations.
But why would it change?
depending on what was selected.
That doesn't make any sense.
Yeah, no, it doesn't make any sense.
If I turn off recalculate, because it should recalculate every frame because we're doing the set thing, right? Isn't that the theory? I'm gonna turn off recalculate just in case it's some weird editor thing, real quick.
That it was off.
It's not. It's on.
Oh.
So let's hit apply. Let's hit play. Let's move our player off of 0 and click in an enemy.
Yeah, we're still getting the problem. So there's some kind of assumption being made somewhere, but it's just a matter of finding that assumption. I think we should let this one fester for a little while.
No, I think we need printfs. I think we need debug log right now.
What time is it that that YouTube starts making the videos wacky?
What? Well, we've not even been an hour yet, so.
No, we're an hour and 15 minutes.
Oh, we are?
We started at 9:05.
Man, we're overtime?
Yeah.
This went so fast for me. It's a 2-hour mark, so we've got some time. Let me just do some quick debug log just because I want to. Oh, who cares? I'm gonna forget it all next episode anyway. So yeah, we'll figure this out later.
Yeah, it seems like this is going to be something that will probably take a little while to figure out what's going on.
I don't think it's gonna take that long. I'm just curious where the logic is breaking down is what I'm curious about.
Well, why does it have anything to do with an editor? Because when you're selected on your player, it's fine.
Or deselected or selected on something else, but if I'm selected on an enemy, it's not.
Then it's not fine anymore.
Do they have something weird, like, where they can't remove enemies from a list if the enemy is selected or something? I don't know.
It's possible.
Interesting.
It only has to do with those enemies being
Here,
selected.
I just want to see. I do want to debug log real quick. I just want to find out.
Can you look at the points, though, and
that's
confirm that?
All right, so we're going to look at the points on... I don't think... Oh, wait, I can open a separate inspector. Hold on. We'll just do add tab, inspector. Let's see if we can really screw things up. And we're going to put this on the player. Actually, let's lock this one, right? Let's put this on enemy 1, and then let's do another one on the other enemy and see what happens. Okay, that didn't do as exciting as I thought it was going to. All right, so this one's our locked one. We're going to put this on our player so that we can actually look at it. Then we're going to actually select our enemy. And so now we've got our player selected here. And we're going to look at... It's not on the player. It's on Bezier laser. So we're going to do that. We're going to unlock, lock, click the enemy. Finally...
So there are 0 points there, see them?
So there's 3 points.
P2 is 0.
So wait, 1, 2, 3. Now if I deselect the enemy,
that's a different enemy.
2. So
yeah,
2 and now it's 3.
But it wasn't a problem with P3 or P2 and P0 not matching. It actually is targeting 0.
Yeah, it is.
In the first
it is absolutely targeting 0.
Mm-hmm.
Okay, I'm officially scared. I'm just going to quit. I'm quitting. I'm out. I'm out for right now. Is there any more changes? Let's just quickly check. Wanted to save, so I double check this stuff sometimes. Well, it did something, and it even changed the player prefab. I mean, why not? Let's just do it.
Kind of weird.
Stuff.
Yeah, it's kind of a weird problem.
All right, well, thank you for joining us. Hope you were as confused as we were during this episode, because, yay, confusion. It's fun for everyone.
Confusing.
No, seriously, though, thank you for joining us, and we'll figure out this one. I'm not apologizing for this episode. I'm done apologizing for episodes. I actually liked this episode, even though it went a little slow and a little long, and it was you know, it's not a great episode, but whatever.
No, it doesn't matter how quick it goes. It matters how much stuff we cover.
So, thank you for joining us tonight. Buy Phil's game. It's called something.
It's called Robot Alone.
I don't know. Like,
you should buy
Robot Alone, yeah. Yeah, I forgot. I've been actually selling your game even while you're gone. So
I appreciate that.
And
yeah, you should
Yeah, don't.
Twitter, email Max.
Yes, email me. I'm a little bit behind on my emails. I have not shipped the stuff out yet. I do have the stuff, the swag, the donation swag.
Should follow
This
Max on
weekend,
Twitter too.
I can probably get it organized, actually, thankfully, because I got a prototype thing done at work today that everyone was really happy with. So, yay! Got something done for work that people are happy with. But yeah, I actually want to show everyone, but I can't. So,
Follow Max on Twitter.
yeah, follow me on Twitter at Drakfire or something. I don't know. It's DRAKFYRE. You can email me at pushypixels@pushypixels.com. That's PUSHY. I'm not going to spell that out. And
You can follow me on Twitter if you want to at Magma Lemur. I usually respond. You can email me if you want to. Chances are low that I'll respond. Philip@protosoftworks.com.
all right. And what's the mailing address for the Jeffrey Hawthorne fan club?
There isn't one.
Oh, okay.
It's
Get on that.
what was it? Pushy Pixels.
Phil needs one, too.
Pushypixels.com.
Phil fan club. The Phil Rate fan club.
Yeah. Oh, I don't want to be the Phil Ray.
Just email
Okay.
Pushy Pixels and he'll forward your messages if there are any.
All right. Yes. If you're like, hey, I want to talk to that Jeffrey guy, just email me. I will totally get you in touch with Jeffrey.
And you should donate.
And actually,
to the show.
same with if you feel uncomfortable emailing the Invisible Man over here, you can email me and I'll totally get it over to him. As
I think
well,
the
so.
hilarity of me being not shown on the show is that my icon is my face.
Yes. Yeah. It's like, what do you look like? It's like, I look like my icon.
That's what I look like.
Why are you invisible on the show?
I don't know.
I don't even
I don't know,
understand.
it's just
I don't
become a
even get
trend
it. It's
now.
a thing. Yeah. So, thanks for joining us, folks.
Yeah.
Have a great night.
Donate to the show.